Hi all, welcome to goclasses. In this session, we are going to discuss mathematical logic, gate PYQs, gate 2026 PYQs of gates yes, gate DA 2026 paper, propositional logic question, first order logic questions. We will do the complete analysis of all these questions. Okay. Don't watch this session like a movie. Take your copy pen. Let's do it together. You also solve, I also solve. Okay. So let's start now. Remember, in this session, we are solving GATE 2026 Computer Science and DA PYQs of Mathematical Logic. If you want to watch the Mathematical Logic GATE PYQs of all the remaining years, then you can watch in this playlist. Okay, on the YouTube, you can search Go Classes Discrete Mathematics. This playlist you will find basically on YouTube. You can just put it. Search on YouTube, Go Classes Discrete Mathematics. This playlist will be there. You can see Discrete Mathematics Gate PYQs, summary lectures, revision playlist. And here you can see, for example, Propositional Logic Gate PYQs Part 1, Propositional Logic Gate PYQs Part 2. Also, you will find First Order Logic Gate PYQs Part 1, Part 2. Also, summary lectures, Propositional Logic. Also, you can see Gate PYQs. Okay. So you can search on YouTube, Go Classes Discrete Mathematics, and you can watch it. Okay. Now let's start our session. So our session is basically GATE 2026 PYQs of mathematical logic, propositional logic, and first order logic. Let's solve this question. This is GATE DA 2026 question. The question has defined something new. The question is saying that sentence X is said to entail sentence Y if whenever X is true, Y must hold true. Okay, so a new definition is given to you. The question is saying that we say that X entails Y. Sentence X entails Y. So, what is the meaning of this statement? X entails Y. What is the meaning of this statement? This statement basically means that whenever X is true, then Y must be true. What it means? X entails Y, it means it is basically same as saying that X implies Y, that is true. Correct? Because remember, you can see whenever X is true, Y must hold true. So it simply means X implies Y is true. Whenever X is true, Y must hold true. This whole thing simply means that X implies Y is true. Okay, X implies Y is true. Correct? So I can say that X entails Y. This statement is similar to, or I can say this is equivalent to saying that X implies Y is true. X implies Y is true. Okay, very simple. Now let's see. The question is asking which of the following statement is or are correct if X entails Y. Means it is given that X entails Y. Okay, now remember, the question is saying that it is given. It is given. What is given? It is given that X entails Y. Okay, so this X entails Y, this is already given. What it simply means? It simply means that X implies Y is true. This is given. X implies Y is true. Remember, X implies Y is true. This whole thing is given. Okay, now you tell me, if X implies Y is true, then what are the possible truth value combinations of X comma Y? Let me know. If I tell you that X implies Y is true, then from this information, what can you say about the possible truth value combinations of X comma Y? What are the possible truth value combinations of X comma Y? Tell me. If X is true, Y is true. Yes, this is possible. If X is false, then also X implies Y will be true. So X can be false, Y can be false. X can be false, Y can be true. Correct? Okay, agree. But remember one thing, which is not a possibility. X true, Y false. This is not a possibility. This is not possible. But these are the possibilities. But these are possible. Okay. So remember, we can simply say that either x is false or y is true. Okay, so you can see from this information I can say that I can I can say that either x is false or y is true. Correct, because you can see either x is false or y is true. So I can say these three combinations are possible, and these three combinations basically they imply you can see they imply that either x is false or y is true. Okay, I hope you understood this. So finally what we know that from here I can say that x y, the possible combinations are true true, false true, or false false. Okay, these are the possible combinations. Only these are the possibilities. Okay, so you can see the question is asking which of the following statement is or are correct. So tell me, is this correct that x implies y? Yes, because x entails y itself means that x implies y is true. Yes or no? So you can see that x implies y, that is true. Yes, that is true. Okay, so you can see yes, this is a true. Okay, what about if x then y? This is same as option A. If x then y, yes, this is also true. If y then x, can I say y implies x? Can I say this will be true? No, I cannot say, because you can see, take this scenario, take this scenario. Here you can see y is true, x is false. Okay, then this will become false. If y then x, this will become false. Do you agree? So I can say that this is this is not true. Okay, yes or no? Very simple. What about this one? X and negation y is false. You can see in this case also x and negation y is false. In this case also x and y negation is false. In this case also x and y negation is false. Yes or no? So you can see that this whole thing, this is also true. Okay, correct? Because you can see these are the three possibilities. In all these three possibilities, you can see that this statement x and y negation is false. This statement is true. This statement is correct, I can say. This statement is correct because you can take you can consider all these three possibilities and you can find what is x and y negation. Then for all these three possibilities, x and y negation, that is coming out to be false. And yes, this statement B, this is also saying that x and y negation is false. Correct? Okay, so I can say that option A, that is also correct. Option B is also correct. Option C is also correct. But option D is not correct. And what is the counter example for option D? Can anyone tell me what is the counter example for option D? That is, you take x false and y true. Okay, this possibility. I hope you understood. So this is a simple question in GATE DA 2026. I hope you understood the complete analysis of this question. Very simple. Remember one thing, that in this question, this entails, this new definition is given in this question. You need to analyze this definition, this given terminology, you need to analyze, and then you need to solve this question. Many times in the GATE exam, they will define something new in the question. So you have to read the definition given in the question. Then based on that definition, you have to solve the question. Okay, so this type of questions, they come in the GATE exam where something new is defined. Okay, in this GATE DA 2026 question that we have just now solved, let's see one more explanation of option B. Okay, do you remember I told you that when we say that P is true, if I want to say P is true, whenever I want to say P is true, then how do we write it? We write it directly P. Agree? And do you remember I told you that whenever I want to write P is false, then how do I write it? In our lectures, we have seen this. Whenever I want to write P is false, then how do I write it? I can write it P bar. Do you remember? In our lectures, we have seen this. Now notice, the question is saying that x entails y, this is given to you. Okay, this is given. X entails y, this is given. What it means? X entails y, this simply means that whenever x is true, y is true. It simply means x implies y is true. Okay, now notice, Here, think of this as a P. Okay, here please understand that this is, take it as a P. This is P. Now, what this whole option B, what I can write it? For this entire option B, what I can write it? For this entire option B, can I say that option B I can write as X and Y negation whole bar? I can write it because I told you in our lectures that whenever I want to write P is false, then I can write P bar. Whenever I want to write P is true, I can write P. So I can say that this whole statement, option B, the whole thing, I can replace this whole thing, I can replace with X and Y bar whole bar. What that will become? That will become X bar or Y. What is X bar or Y? That is X implies Y. That is same as option A. That is same as option C. That is same as option B. Okay, that is same as the given statement. Okay, yes or no? So this is another explanation for option B. I hope you understood. So this is the complete analysis of this question. Let me know, did you understand? And what about this method? This particular method for option B that I told you just now, did you like it? I think this is another way to see it, I can say. This method, this is another way to see the option B. I hope it is clear. Okay, let's move on now. Let's solve GATE DA 2026 question. Let Px be a predicate. Which of the following statements is or are not valid in first order logic? What is valid? In the first order logic, what is the meaning of valid? Valid means always true. Do you remember? Valid means always true. Means whatever domain you take, whatever predicate you take, always true. Valid means always true. In first order logic, valid means always true. The question is saying that which is not valid. And remember one more thing, that in the first order logic, we take the domain to be non-empty. Domain is by default always non-empty. Okay, so never take empty domain unless the question mentions to take the empty domain. Never take empty domain, means the domain is by default always non-empty. Okay, now let's see which of these statements is not valid. For all x px implies there exists x px. This is valid because if LHS is true, then RHS will be true. This is an implication statement. Remember, if LHS is true, means for everyone in the domain P is true, then definitely for someone in the domain P will be true, because the domain is always non-empty, remember. If the question explicitly says that domain is empty, then we have to consider empty domain. Otherwise, always consider non-empty domain. Okay, so this is your domain. This is your domain. And the domain is always non-empty. Let's assume this is the domain. Now you can notice, what about option A? Option A is saying that LHS implies RHS. You can see if LHS is true, means for every element in the domain, if P is true, then definitely for some element in the domain P will be true. Means if LHS is true, whenever LHS will be true, then definitely RHS will be true. So I can say that this is valid, or I can say this is always true. Whatever domain you take, whatever elements you take in the domain, whatever predicate P you take, you will see that this statement A is always true, because whenever LHS will be true, then automatically RHS will be true. For every element, if P is true, then for some element, definitely P will be true. So this is valid. Okay, next, what about option B? There exists x px implies for all x px. This is not valid. Can you give me a counter example for this? Option B is saying there exists x px, means in the domain, if for some element if P is true, then can I say that for all the elements P will be true? Remember, this is LHS and this is RHS. Can I say this option B is always true? Can I say? No. You can easily give me a counter example. For example, what you can do, you can take domain to be set of natural numbers, and take P as X is prime. Now you can easily see, if I take domain to be natural numbers and Px is X is prime, then you can see the LHS is true. There exists an element in the domain for which P is true, means there exists an element in the domain which is prime, yes. But you can see every natural number is prime, no. So you can see that in this situation, B will become false. In this situation, what B will become? B will become, in this situation, B will become true implies false, which is false. So I can give you a situation where option B is false. So option B is not always true. Not always true means not valid. So I can say that this B is not valid. Very simple. Okay, so I can say that this is invalid, means not always true. What about option C? There exists xpx by implication for all xpx. Of course, this is also invalid, because by implication means that this side also. Notice, this side is true, but this side is not valid. Okay, so you can see, because option B is invalid, so automatically option C will be invalid. Very simple. What about option D? For all xpx implies there exists x negation px. Can you give me a counter example for option D? Means, can you make this option D false? Option D is saying that for all x px implies there exists x px bar. There exists x negation px. So what it means? Notice this option D is saying that in the domain, if for every element if P is true, then there is some element for which P is false. Actually, if you notice this statement, if you notice, can I say this statement will always be false? Can I say this statement will be always true? Can I say sometimes true, sometimes false? What can I say about it? This option D. A very simple question I'm asking. First, let me solve this question, then I will do the complete analysis of this option. So you can see, first of all, this is not always true. Can you make it false? This option D, can you make it false? Let's make it false. What I can do? I can take domain. I can take, for example, domain to be set of even numbers. Or I can take domain like this. I can take domain as 2, 3, 5. Take this domain and take Px equal to x is prime. Okay, now you can notice in this situation what option D will become. Notice that what this LHS will become. This is the domain 2, 3, 5, and Px means x is prime. So what this LHS will become? For every element in the domain, P is true. For every element in the domain, P is true. Yes. So true implies. What about RHS? There is some element in the domain where P is false. There exists X in the domain for which P is false. So no, there is no element in the domain where P will be false. Actually, for every element, P is true. So I can say that this will be true implies false. So that overall becomes false. So I can say that this option D is invalid, because this option D is not always true. Invalid means not always true. Okay, so remember, this option D, this is also invalid. Now we will do the complete analysis of option D, but remember the answer will be what? Which is not valid. So the answer will be option B, C, D. Okay. Now let's do the complete analysis of option D. You tell me, if I ask you for option D, I ask you, this will, what can I say? Option D, can I say always true? Can I say always false? Can I say, remember, always true means valid. Always false means unsatisfiable. Unsatisfiable. Can I say satisfiable? but not valid. Tell me which is correct. Very interesting question. Which is correct? Give me the answer. Some students are saying always false. No, this is an implication statement. To make it true, just make this LHS false. That's it. Students who are saying that this option D is always false, they are thinking that if this is true, then this will definitely be false. So overall, this whole thing will be false. But they are not thinking that what if this itself, LHS itself, is false? If LHS itself is false, then the whole thing will become true. This is an implication statement. LHS implies RHS. To make this implication true, just make LHS false. Don't worry about RHS. Just make LHS false. So remember, the answer will be what? The answer will be satisfiable but not valid. Okay, please understand that I can make it true, I can make it false. We have already made it false. We have already seen that this is invalid. Okay, see, invalid we have already seen. Invalid we have already seen. But it is satisfiable means I can make it true. Okay, see, to make it true, what I can do? To make it true, just make LHS false. Okay, for example, what I can do? Just take this domain. Domain takes set of natural number, and px you take x is prime. Okay, now you tell me. Now, in this I can say situation, this LHS will become false. False implies this RHS actually will become what? That will become true. False implies true. That whole thing will be true. So remember, I can make it true, I can make it false. So it is invalid, but it is satisfiable. The answer will be option 3. Okay, statement 3, or I can say this option 3. I hope you understood. So this is the GA 2026 question. We have done the complete analysis of this question. I hope you understood. Very simple question. Okay. Let's solve GATE DA 2026. Another question. Which of the following statement is not true? The names of the predicates are intuitive. This line is actually very important. The names of the predicates are intuitive. Means you have to use your intuition as well. This is the interesting line. You have to use your intuition as well. Okay. So let's use our intuition to solve this question. Basically, our knowledge plus our intuition we will use to solve this question. Okay. I will tell you where intuition will be used. Okay. So let's see. What about option A? Option A is saying for all x, for all y, classmate x comma y implies classmate y comma x. One thing you notice here proper parentheses are not given. Can anyone tell me? Should I consider like this or should I consider like this? Can anyone tell me? Remember, you need to use your intuition as well. You have to understand the question maker's feeling. What the question maker was feeling when the question maker was making this question, what he felt, what he wanted to convey. You have to understand that also. So, can anyone tell me? Because here proper parentheses are not given, should I consider that okay, this is one thing and this is another thing? Should I consider like this? Or should I consider that this whole thing is one thing? The answer is, notice, if you think for a moment, if you think okay, that this is one thing and this is another thing, then there is a problem. What is the problem? Now there is a problem that here this x comma y are now free variables. See, these are the bounded variables. That is fine. Okay, here there is no free variable. here there is no free variable. But notice that now these will become free variable. This x comma y, they will become free variable. And when you have free variable in a statement, in this whole statement, if you have at least one free variable, then can I find true or false for this statement? Tell me. I am asking, in this whole expression, if there is at least one free variable, then can I find true or false for this expression? No, I cannot find. So you can see that if I consider this whole thing as one and this whole thing as another, then there is no way I can find true or false, because the presence of free variable means that now this is not a proposition, and now I cannot find true or false for this. Yes or no? So now we can't find true or false. Why we can't find true or false? Because now this is not a proposition, because the presence of free variable simply means this is not a proposition. Okay, if it is not a proposition, then we cannot say true or false for this. So the question maker is thinking what? The question maker who made this question, the question maker was actually thinking like this, but he forgot to put the parenthesis. Okay, so let's put the parenthesis. Now you use your intuition for predicate. Tell me one thing. The classmate predicate, is that symmetric? If you are my classmate, then can I say I am your classmate? If x is classmate of y, then can I say y is classmate of x? The classmate thing, the classmate relation, is it symmetric? Yes, this is symmetric, but is it given in the question? Is it given that classmate relation is symmetric? Means if you are my classmate, then can I say I'm your classmate? If P is a classmate of Q, then can I say Q is classmate of P? Intuitively, yes. But is it given that classmate relation is symmetric? Is it given? No, it is not given. But remember, the question is saying the predicates are intuitive. So you have to use your intuition as well. So remember, the classmate predicate, that is actually symmetric. So for all x, for all y, means whatever two people you take, same or different, whatever two people you take, if x is classmate of y, then can I say y is classmate of x? Yes. Do you agree with me? I hope you understood that for every x comma y, I can say whatever two people you take, same or different, I can say that if x is classmate of y, then y is classmate of x, because classmate relation, that is symmetric. So yes, intuitively this is true. So this word intuitive, okay, we have to use our intuition also for these predicates. This predicate, classmate predicate, this is symmetric predicate. Classmate relation is symmetric relation. So this option A, this is true, because for every two people I can say that if x is classmate of y, then definitely y will be classmate of x. Means if x is classmate of y, then I cannot make it false. If LHS is true, then I cannot make RHS false. Okay. So finally I can say A is true. The question is asking not true, but actually A is true. Okay. What about option B? Option B is actually very simple. For all x likes x comma ice cream implies. See, there are double negation here. So you can actually simplify the RHS, you can simplify. Okay, let's see what will be the simplification of RHS. You just tell me. Let's see option B. Option B is something like this. In the option B, we have for all x, for everyone, we are saying that likes x comma ice cream. X comma ice cream. Okay, means for everyone I am saying that x likes ice cream. If this happens, then this happens. There is implication here. There is implication. Implication. Negation. There exists x. Then again negation. Likes x comma ice cream. Okay. Now you notice something very easy here. You already tell me negation there exists x, negation px. What I can write it? What I can write it? Remember, negation there exists x alpha. I can write it. I can take this negation inside. So this there exists will become for all. So it will be for all negation alpha. So the same thing I will do here. This negation I can take inside. Then this there exist will become for all. So it will be for all. And this negation that will basically cancel. And I can say it will be for all x px. So what can I say this option B? This option B basically I can also rewrite. Option B is like this. That LHS and RHS they are basically same. Correct? LHS, RHS they are basically same. It's like alpha implies alpha. Notice this LHS, RHS they are same. Alpha implies alpha. Alpha implies alpha. That is what? That is alpha bar or alpha. That is what? That is true. Okay. So you can see that option B that is also true. I hope you understood. Okay. Let's see option C. Each king is a person is equivalent to for all x. It's a king and it's a person. No, this is not equivalent. Yes or no? This statement option C this is false. Why? Notice one thing. Every A is B. How do we write it? Do we write it like this that for all x A and B? No, we don't write like this. Yes or no? Okay, so you can see I am saying look at option C. Notice we already know this. This template, if you remember, template every A is B. Every A is B. How do we write it? Every A is B. Each A is B. All A's are B's. Okay, this same statement I can also say each A is B. This same statement I can also say all A's are B's. Okay, so you can see these things, these statements are basically same. Now tell me this template, how do we write in the first order logic? We write it like this that for all x, if you are A, then you are B. For all x, if you are A, then you are B. Means every A is B. Means if you are A, then you are B. All A's are B. Means if you are A, then you are B. Okay. Tell me one more thing. What this statement means if I write like this for all x, AX and BX. Tell me what it will mean. For all x, AX and BX. What it will mean? It will mean that everyone in this whole universe, everyone is A as well as B. Yes or no? This simply means that everyone, every element is A and B. Everyone is both A and B. Both A and B. Tell me, are they same? This statement and this statement, are they same? Everyone is both A and B. And this statement is saying that every A is B. Are they same statement? This statement, are they same statement? No. No, they are not same statement. For example, I can say that here, I can say that, for example, rich person, every rich person is popular. Okay, every rich person is popular. And this statement is saying that everyone is rich and popular. Both are different, right? This statement is saying every rich person is popular. And this statement is saying that everyone is rich and everyone is popular. Definitely, they are not equivalent. So, overall, you can see option C. Option C is saying each king is a person. Option C is saying that each king is a person. Actually, this is equivalent to, this actually will be equivalent to what? Every king is a person means for everyone, I am saying that if you are a king, then you are a person. And remember, this is not equivalent to saying that everyone is king and everyone is person. Okay. So I hope you understood this. So option C, that is actually false. What about option D? All humans are mortal. This is the same template, or A's are B's, and this is equivalent to For every x, I am saying if you are A, then you are B. If you are A, then you are B. Yes, so this statement is actually true. The question is asking which are not true, so the answer will be option C. So for this question, answer will be option C only. I hope you understood this question. Now let's move on. Let's solve GATE CS 2026 set 1 question. A very simple question from propositional logic. When the teacher is in the room, all the students they stand silently. If the above statement is true, this complete statement is true means when the teacher is in the room, when then all the students will stand silently. So if the above statement is true, then which of the following statement is not necessarily true? Notice what is given here. You tell me what is the given statement. The given statement is that when this is a if then statement, please understand. It's like this, that when then this teacher, okay, I can say it's like alpha and it's like beta. So when alpha then beta, it simply means alpha implies beta. Okay, so it will be when teacher is in the room, when teacher, I can say it's like tx, or just simply say faculty teacher, or okay, let's use teacher. Teacher in the room. Okay, means when teacher is in the room, when teacher is in the room, then what will happen? Then all the students will stand silently. All the students will stand and silence. Okay, so you can see if the above statement is true, means this entire statement is true. If teacher is in the room, then all students, all students, all students will do one thing, two things actually. All students stand and silently. Okay, so it's like silently. It's like doing the two things. Yes or no? Okay, very simple. So this complete statement is given to you as true. This is it true. So tell me one thing. Can I say if teacher is in the room, then all the students will stand? Yes, I can say that. If teacher is in the room, then definitely all the students will stand. Can I also say that if the teacher is in the room, then all the students will be silent? Yes, that is also correct. Because when the teacher is in the room, then all the students will do two things. One is stand, another is being silent. Okay, now the question is saying if the above statement is true, then which of the following is not necessarily true? Let's read the statements. Let's read option D. When the teacher is in the room, all the students are standing. Yes, that is correct. Actually, that is necessarily true. The question is asking not necessarily true. So actually, this is necessarily true. This is necessarily true. When the teacher is in the room, then all the students will be standing. This is necessarily true. When the teacher is in the room, then all the students are silent. This is also necessarily true. Necessarily true. Okay. What about option C? If all students are standing, then the teacher is in the room. No, we cannot say this. Notice, we can say that if the teacher is in the room, then all the students will do two things. They will stand and they will be silent. But this is just an implication statement. Okay. If the teacher is not in the room, then we cannot say anything. Or I can say that this is like P implies Q. Okay, this is like P implies Q. And this is not equivalent to Q implies P. We cannot say that if all the students are standing, then teacher is in the room. Maybe all the students are playing. Maybe it's interval and teacher is not in the room and all the students are they are standing in the room. That's possible, yes or no? P implies Q is not equivalent to Q implies P. So if you notice this option C, that is saying if all the students are standing, then the teacher is in the room. No, we cannot say. We can't say this. So this option C, this is not necessarily true. Okay, I hope you understood. Let's see option A. If any student is not standing silently, then the teacher is not in the room. Yes, this is actually necessarily true. Why? What is the reason? Notice P implies Q, that is equivalent to negation Q implies negation P. Do you agree? We already know this, that P implies Q, that is equivalent to negation Q implies negation P. So I can say that what will be negation Q implies negation P? Negation Q implies negation P. That means if any student, see, the given statement is saying that P implies, means if the teacher is in the room, then for every student it's like this. If the teacher in room, if the teacher is in the room, implies for all, for all x. Okay, because all the students will do two things. All the students will do two things for all x who are students. For all x who are students. Okay, for all x who are students, they will do two things. What are the two things? They will do two things. They will stand and they will be silent. All the students will do these two things. They will stand, they will be silent. Now you can see it is like this is P and this whole thing is Q. And we know that P implies Q is equivalent to negation Q implies negation P. So what will be negation Q implies negation P? That will be, what will be negation Q? Negation of for all, what that will become? What is negation of for all alpha? That will be, this negation will go inside, this for all will become there exist negation alpha. So here you can see it will be negation Q implies negation P. That means it will become there exist x who is a student. There exist x, I am talking about the students. Okay, so there exist x who is not standing or not silent. Okay, it's like this: stand and silent, whole bar. Okay, correct, because you can see negation of for all x alpha, that is there exist x negation alpha. So it will be there exist x, there exists a student who is not standing or silent, implies P bar means teacher not in room. Teacher not in room. Okay, so you can easily see that this statement is equivalent to this statement. So I can say that if there is any student who is not standing or who is not silent or who is not standing silently, then definitely teacher is not in the room. Is this clear? Basically, I can say, remember, three things I can infer from given statement. From given statement, I can infer actually many things. From given statement in question, these are what I can infer. These can be inferred. These can be inferred. What can be inferred? I can infer that if any student not standing silently, any student not standing, okay, forget about silence. If there is any student not standing, then definitely teacher not in room. Because if teacher is in the room, then all the students will stand. Yes or no? Then teacher not in room. You can see. Similarly, the second thing I can say, if any student not silent, then also teacher is not in the room. Yes or no? Then also teacher is not in the room, because if the teacher is in the room, then all the students will be silent. So if there is any student who is not silent, then teacher is not in the room. And remember, if any student not standing silently, okay, then also I can say that teacher is not in the room, because if the teacher is in the room, then definitely all the students will stand silently. Okay, so finally I can say that this option A, this also is necessarily true. If any student is not standing silently, then the teacher is not in the room. Okay, very simple. So for this question the answer will be option C. I hope you understood. Let's solve GATE CS 2026 set 1 question. Consider the following Boolean expression of a function f. So this expression f is given to us. P comma q, these are Boolean variables, or I can say propositional variables. Which of the following expression is or are equivalent to f? First, to simplify f is given to you. F is an expression, or I can say f is a function, Boolean function, or I can say Boolean expression, or I can say propositional expression. And p comma q, these are the Boolean variables, or I can say propositional variables. And this is p bar or q exclusive or p bar q. P bar q. Let's simplify it first. You already know what is x exclusive or y, what that will be. That will be x bar y or xy bar. Now you can see here what it will become, x bar y or xy bar. Okay, so it will be like p bar or q whole bar, p bar q means x bar y or xy bar, xy bar. Okay, so let's further simplify. Here you can apply the De Morgan law. It will be pq bar, pq bar, and this is p bar q. You know what will happen here? P bar, that itself will be false. So this whole thing actually will be false. Okay. What about this? Here you can apply the De Morgan law. The De Morgan law will be P or Q bar. Correct. Okay. So now you can see P bar P, that will be false. P bar Q bar you will get. P bar Q bar you will get. Q QP you will get. Q bar will be false. Okay. So you can see finally what you got. You got PQ or P bar Q bar. What is that? That is by implication. Yes or no? That is by implication. And remember, by implication is complement of exclusive or. Okay, yes or no? So this is f. F is basically complement of exclusive or I can say f is basically by implication. So remember, when I simplify f, it will become p by implication q. Okay, or I can say it will become p exclusive or q whole complement. Okay, now which of the following expression is equivalent to f? Yes, option A is equivalent to f. Option B is not equivalent to f. What about option C, comma D? Let's see what is p bar. What is p bar exclusive or q? What that will be? Here you can see it is x, it is y. So that will be x y bar or x bar y. So x y bar or x bar y. Okay. So what it will become? It will become pq or p bar q bar. And that is what? That is same as by implication. Yes or no? So yes, this is also equivalent. Okay. And similarly, you can see what about option D? P bar exclusive or q bar. Okay, let's see this one also. P bar exclusive or q bar. Here you can notice it is x, it is y. So it will be x bar y or xy bar. So x bar, okay, x bar y or x y bar. So you can see what it will become. It will become PQ bar or P bar Q. That is basically same as P exclusive or Q. But our F is basically P exclusive or Q whole complement. So this is also not equivalent. So for this question, the answer will be option A, comma C. Very simple question. I hope you understood. Now let's move to the next question. Let's all GATE CS 2026 set to question. When it is raining, peacocks dance. Based on this statement, based on this sentence, which one of the following options is necessarily true? First of all, this given sentence is if then statement. When it is raining, then peacock dance. Okay, so I can say the given statement is basically, you can see, it is raining implies peacock dance. Okay, it's like rain, rain implies dance. Okay, peacock dance. Is this clear? So now, based on this sentence, means this is given to you as true. Means whenever there will be rain, then peacocks will dance. Now, based on this, which option is necessarily true? You already know this is equivalent to D bar implies R bar. Means if peacocks are not dancing, then there is no rain. Also remember, R implies D, that is not equivalent to D implies R. Okay. Also remember, R implies D, that is not equivalent to R bar implies D bar. Okay, yes or no? R implies D, that is not equivalent to R bar implies D bar. Okay, yes or no? We already know that any conditional statement is logically equivalent to it's a contrapositive. This is contrapositive. Okay, yes or no? This is a converse. Any implication statement is not logically equivalent to its converse, and this is inverse. Any conditional statement is not logically equivalent to its inverse. So now let's see which of the following option is necessarily true. So this is necessarily true that if peacocks are not dancing, then there is no rain. When peacocks are not dancing, then there is no rain. So option C. Actually, option C is what? That is D bar implies R bar. And this is equivalent to R implies D, that is given to you. Okay. You can see option A is peacock dance only when. Do you remember about only if? How can I write A only if B? And how can I write A if B? Do you remember? How do I write this? How do I write this? If you remember, this is very easy. It's like if B then A. Okay, if you remember, this is like if B then A. And that is same as B implies A. That is same as B implies A. Okay, B implies A. So remember, this is B implies A. Or I can say that this if this goes in the backward direction, only if goes in the forward direction. So you can see A only if B, that means A implies B. All these things we have seen, all these concepts we have studied in detailed way. Now let's see. So you can see peacock dance only when it is raining. Only when means this will go in the forward direction. So it will be like dance implies rain. And this is not equivalent to rain implies dance. Option B, when peacock dance, it is raining. It is also D implies R, which is not equivalent to R implies D. The given statement is R implies D. The given statement is R implies D. This is the given statement. Okay. Now let's see. When it is not raining, peacocks do not dance. It's like when it is not raining, then peacock are not dancing. And this is not equivalent to R implies D. Okay. So finally, I can say that answer will be option C. So very simple question. I hope you understood. Let's solve GATE CS 2026 set 2 question for two different person x comma y. The predicate mxy denotes x knows y. Read this predicate. M x comma y means x knows y. Consider the following statement. There is a person who does not know anyone else, but that person is known by everyone else. There is a person who does not know anyone else, but that person is known by everyone else. For example, just I'm giving you one example. For example, let's assume Virat Kohli. So for a moment, assume that Virat Kohli does not know anyone else, but everyone knows Virat Kohli. It's like that. Okay, something like that. So now let's see which of the following expression represents this statement. So this is actually a simple question. What the statement is saying, that there is a person. So there exists. We will have to start with there exist. There is a person who does not know anyone else, but that person is known by everyone else. So it's like there is a person, there exists X, there is a person, and what this person has, what property this person has. Let's see what property this person has. So this person has these two properties. What are the two properties? Remember, there are two properties, this first property and second property. This person has two properties, first and second property. What are the first property? So there is a person who does not know anyone else, means there exists X such that for everyone, for every y, what I can say, for every y I can say that if X and Y are different, then X does not know Y. Okay, if X and Y are different, then X does not know Y. Then X does not know Y. Do you agree with me? Very simple. Step by step I am going. Notice there is a person. Okay, there is a person. So this becomes there exists X. There exists X. Okay. Then we have who does not know anyone else. What it simply means, that for all y I am saying, for every y I am saying that if X and Y are different, then one thing is clear, that X does not know Y. Okay, correct. But means and. If you remember, I told you but means and. But means and. So you can see and. There is and here. And what is the other part? The other part is that person is known by everyone else. That person is known by everyone else. Means everyone else knows this person. What it means? Again, I can say that for all y, I can say, or for all z, that's fine. Okay, you can say for all y, because anyway, the scope of this y is only this. Okay, so again, you can use y. This y and this y, they will be different y. Okay, because the scope of this y is only this area, and the scope of this y will be this area. So again, I can say that for all y, one thing I can say, what I can say, that for all y, if X and Y are again different, then I can say that Y knows X. Y knows X. Means everyone knows X. Everyone else knows X. So this is how I can write. Okay. I hope you understood. Now let's see, let's notice the options. In the options, they have taken the for all outside. Okay. There is another way to write it. It's like this, that there exists a person for all Y. Okay, it's like this. What we can do, we are taking this for all y we are taking outside. Okay, now what now? So you can see I am saying there exists a person, so that for all y, what I can say, I can say that if X and Y are different, if X and Y are different, then two things will happen. Okay, see, very simple, just use your common sense. I am saying there is a person, definitely there exists X. There is a person, so it means we will start with there exists X. Now, for everyone, we are saying, for every y, we are saying that if X and Y are different, then two things will happen. What are the two things will happen? The two things will happen if X and Y are different. Two things will happen, that X does not know Y, X does not know Y, and Y knows X. y knows x does not know y, and y knows x. So, like this also we can write. I hope you understood. So, remember, there exists a person such that for everyone I am saying that if x and y are different, then two things will happen. X does not know y, but means and y knows x. Okay, so finally the answer will be what? There exist here. Please understand. Okay, something you understand that they are starting with y. So what you can do? If I replace x with y with x, I can do that, no problem. Okay, there exists y. What you do in this whole expression? Instead of x you put y, instead of y you put x. Means there exists y for all x such that if x is different from y, then two things will happen. What are the two things? You can see y does not know x, and y does not know x, and x knows y. Okay, so very simple. Now let's see, because notice one thing that they are having y, this this variable y with their exist. Okay, this variable y with their exist. So now let's see. You can see this is clearly wrong. There exist for all wrong, for all there exist wrong. Automatically the answer will be option A. Option A will be the answer. There exist y for all x such that if x and y are different, then two things will happen. What are the two things? You can see x knows y does not know x. You can see x knows y does not know x. Yes, option A will be correct. Very simple question and very nice, very beautiful question. I hope you understood. A very nice option is also possible. A tricky option is possible. What is that? Can anyone tell me? A tricky option is possible. For example, if they give you this type of option, there exists y for all x. What they do? They make a small change only. They say that they what they do? They just make a small change here. Here they write, m yx and negation mxy. Okay, so this type of small change if they do, then it will become a tricky option. Okay, because please understand that this expression is also correct, this expression is also correct. Here you notice with there exist we are using variable x, here with there exist we are using variable y. So you have to see which variable they are using with there exist, which variable they are using with for all. Okay, so anyway, this is also, I can say this also will be wrong. This also will be wrong. Okay, so the answer will be option A. I hope you understood. Very simple question. Let's solve GATE CS 2026 set 2 question. Which of the following option is not a property of Boolean algebra? Remember, Boolean algebra is isomorphic to propositional logic. Boolean algebra, propositional logic, these are basically same things. So which is not a property of propositional logic, or I can say which is not a property of Boolean algebra? This is OR operation, disjunction. This dot is AND operation, conjunction, and this is not operation, that means complement. Okay, A or B equal to B or A. This is a commutative property. Yes or no? Yes, this is a property of Boolean algebra. A or B equal to B or A. So yes, the question is asking not a property. This is actually commutative property. This is commutative property of OR operation. So commutative property have two things. What are the two things? Like AB equal to BA, A or B equal to B or A. Okay. So here you can see this is also commutative property. AB equal to BA. This is also a commutative property. What about AA bar equal to 1? This is not a property, because remember AA bar, that is A and A bar, that is actually equal to 0. 0 means false. A or A bar equal to 1. Yes, this is a property that A or A bar that will be 1. It's like, P or P bar will be true. Okay, so yes, this is a property. So the question is asking not a property, the answer will be option B. Very simple question. I hope you understood. So that's it. We have completed GATE 2026 previous year questions, GATE 2026 questions of propositional logic and first order logic. Did you notice? In GATE 2026, there are many questions from mathematical logic. 4 questions in GATE DA 2026 from mathematical logic. Only from proposition logic and first order logic, there are 4 questions in GATE DA 2026. Also, we have done GATE CS Set 1, GATE CS Set 2 2026 questions of mathematical logic. I hope you understood each and every question. We have done the complete analysis of each and every question. I hope everything is clear. Thank you, everyone. Please like this session and please comment on this session. Okay, thank you.